Inverse of function from graph. I'll appreciate if you copy this graph, stop the video, and then answer the questions. Once you have answered the questions, then look into my solution. The question here is, we are given a graph and you need to sketch inverse of the given function. Is the inverse of the given function a function? How can you predict the above result from the graph of the given function? So that is the question at present. Now let's go from 3 to 1. How can you predict the above result, and what is the result we'll try to figure out from the graph? And the question here is the inverse of the given function a function? Now what is the test to figure out that the inverse will be a function? The test is horizontal line test. So if you draw a horizontal line and if it strikes at more than one point, then the inverse is not a function, right? So answer for the third one is that inverse, that means f inverse, is not a function. And how will you predict? It is from horizontal line test. So always when you are given a function or a relation, just draw a horizontal line and then you can test that if you find inverse of this, then it won't be a function since it fails horizontal line test. Now from the graph, how to draw inverse? Now we'll use this line y equals to x, which I've already drawn here. This is not the part of the function. The function is in black bold. So this is the line which is y equals to x, and if we reflect our graph on this line, then we get the inverse of a function. So that is one way of doing it. Another way of doing it is to find the coordinate points and then swap them, right? So both ways we can do this question. So let's first do it with the coordinate points and then we'll flip and check the answer. So let me first label all the points. Let's say this point is A, this is B, this be C, D. These are our critical points, right? Now for each point we will write down their coordinates. So point A is minus 3, 0. Point B is minus 1, 3. Point C is origin 0, 0. D is 3, 4. And E is 4 and 1. Now if you have to find inverse of the function, so what you need to do is flip the points. So we'll say f inverse, we'll denote it by dash, will be 0, minus 3. So we interchange x and y. B will be 3, minus 1. C will be 0, 0. The points which don't change, they're called invariant, and they will lie on our line y equals to x. This is the line y equals to x for us. 4, 3 and E dash will be 1, 4. So these are the images which you will get once you swap x and y coordinates, right? And these will result into inverse of your function. Now I should not write here, I just write inverse here, and that is my function f of x, right? So once you do inverse, which we know is not going to be a function, so we should not write inverse within bracket x. It is inverse of the relation, okay? Now let's do graphically and find out where the image of A will be. So A, treat this y equals to x as a mirror, and if you see from A, then diagonally we come 1 and a half. We go half and 1. So we get this point which is 0, minus 4. So, sorry, which is 0, minus 3, correct. Minus 4 is here, 0, minus 3. So that is correct for us. Now for B, let's count. So we go diagonally, we get 1, 2. So 1, 2. So that is the position of B dash, right? So we'll write B dash here, and the coordinates for B dash is 3, minus 1, which is 3, minus 1. Similarly, C will be the same point, and D, half units, so half unit is here. So we get D here, which is 4 and 3. 4 and 3 is correct. For E, we can go 1 and a half, half and 1, right? So we get reflection of E, which is E dash, and this is D dash. E dash is 1 and 4, 1 and 4. So that is how we can get our image points. And now we can always connect them. And once you connect these points, then you get the inverse of the given function, right? So A to B, you will find that the points which are on x-axis, they come on the y-axis, and those which were on the y will go to x-axis. So that is how they kind of reflect. So A, B, C, D and E. So that is how you can draw your inverse of the given relation. So we got A, B, this is C is same as C dash. That is called invariant point. Things when it is exactly same, then we call them invariant, right? So that is invariant. So I'll write here invariant. So these are the points which will lie on the line y equals to x. So that is how these problems should be done. I hope you understand. Thank you.